Architecture has always been about solving problems. For thousands of years, architects have worked to create spaces that are more beautiful, more efficient, and better suited to the way people live. But today, a new tool has entered the world of architecture: coding. And that raises an interesting question. Does learning to code make an architect a better designer? Or is coding actually changing what it means to be an architect in the first place? Let's start with a very simple example. Imagine you're designing windows for a building. In a traditional workflow, an architect might explore a handful of different options, choose the most suitable one, and continue with the design. But what if you had a system that could test thousands of different possibilities? Different sizes, different positions, different types of glazing, and even different sunlight conditions throughout the year. A system that could analyze every option and show you exactly how each decision affects natural daylight, energy consumption, and indoor comfort. This is where coding begins to play a role in architecture. Not because every architect needs to become a software developer, but because coding may change the way architects think about design itself. And that's exactly what we're going to explore in this video. Hello, I'm Hussein and welcome to my YouTube channel. In this video, we're going to explore one of the most debated topics in architecture today. Do architects actually need to learn coding? Is programming simply an extra skill that's nice to have, or can it fundamentally change the way we think about design? By the end of this video, I'll try to give you a clear and balanced overview of the topic without getting into complicated technical details. My goal is to help you understand what's really changing in the industry, so you can decide for yourself whether learning to code is something worth pursuing. Before we talk about coding, let's take a step back. If you look at the history of architecture, there's something quite interesting you'll notice. Architects have always embraced new technologies. There was a time when every drawing was produced by hand. Pencils, paper, rulers, and countless hours of drafting were an essential part of an architect's work. Then CAD software arrived. At the time, many people believed hand drawing would disappear and computers would replace architects, but that never happened. Computers simply became a new tool that made the design process faster and more accurate. A few years later, BIM entered the world of architecture. Once again, many saw it as a temporary trend. Yet today, on many of the world's largest projects, working without BIM is almost unthinkable. Then came Parametric and Computational design. These tools allowed architects to move beyond designing a single fixed form. Instead, they could define rules and relationships that generate many different design possibilities. And now, coding and artificial intelligence are becoming more prominent than ever. When you look at all of these changes together, a clear pattern begins to emerge. Every generation of architects has introduced new tools into the design process. At first, some of those tools seemed unfamiliar, complicated, or even threatening. But over time, they became a natural part of the profession. That's why it may be more useful to see coding not as a revolution, but as the next chapter in the long relationship between architecture and technology. Because in the end, none of these tools were created to replace architects. Their purpose has always been the same: to help architects understand complex problems more clearly, make better informed decisions, and create better designs. And that brings us to the main question of this video. If coding is simply another tool, what exactly does it change in the work of an architect? So let's come back to the main question. What actually changes when an architect learns to code? Does it simply add another skill to their CV? Or does it change the way they think about design itself? In my view, the biggest change is a shift in mindset. Let me explain that with 3 simple examples, from designing a form to designing a system. In a traditional design process, architects usually design a specific form: a building, a roof, a particular building mass. In other words, the final outcome is often defined from the very beginning. But when you enter the world of computational design, the approach becomes slightly different. Instead of directly designing the form itself, you start designing the rules that create the form. Imagine you're designing a building. Traditionally, you might spend hours adjusting the position of windows, refining their dimensions, and improving the overall composition. With computational design, however, you can define a set of rules. For example, if a building receives more direct sunlight, the windows become slightly smaller. If the view on one side is better, the openings become larger. If an interior space requires more daylight, the density of the windows increases. At that point, you're no longer designing a building, you're designing a system capable of creating countless possibilities. And that may be the most important shift of all. The architect is no longer designing forms alone, they're designing the relationships, interactions, and rules that bring those forms to life. From one solution to thousands of possibilities. Let's take the window example a step further. Imagine you're trying to find the best window design for a room. If the window is too small, there won't be enough natural light. The space may feel darker, and you'll rely more heavily on artificial lighting throughout the day. On the other hand, if the window is too large, it may introduce excessive heat during the summer, create glare, and increase cooling demands. In a traditional workflow, an architect might compare a few different options. 3 designs, 5 designs, maybe 10. But with coding, it's possible to explore thousands of alternatives in a relatively short amount of time. Different window sizes, different locations, different building orientations, different glazing types, different seasonal sunlight conditions, even the energy performance of each option. A computer can analyze all of these possibilities. But there's one very important point to remember. The computer does not make the decision for the architect, it simply provides more information. The architect still decides which option offers the best balance of aesthetics, performance, spatial experience, and project requirements. In simple terms, coding expands the number of choices available, but the final choice remains a human one, from intuition alone to intuition supported by data. One of the most beautiful aspects of architecture is that not everything can be measured. The atmosphere of a space, the quality of light in a courtyard, the sense of calm a room can create. These things don't emerge from formulas alone, and no great architect designs purely from data. At the same time, we now have access to an extraordinary amount of information. We can analyze daylight levels, we can evaluate energy performance, we can simulate structural behavior, we can predict wind flow, and we can assess how a building might perform long before it is actually built. All of this information can help us make better decisions. So the purpose of coding is not to replace creativity or experience. Its purpose is to strengthen them. It allows architectural intuition to be supported by better information. Instead of relying only on instinct or trusting only the data, we can combine both. And perhaps that's where the future of architecture really lies. A future where human creativity and computational analysis work together, not in competition with each other, but side by side. So far, we've talked about how coding can change the way architects think. But perhaps the most important question is this: does coding make architecture more creative, or does it make design feel too logical, too technical, and too machine-driven? The truth is, there's no simple answer. If you ask some architects, they'll tell you that architecture is, above all, about people. It's about emotion, it's about experience, it's about culture, memory, and the way we live. And they're absolutely right. No algorithm can measure the feeling of walking through a historic courtyard. No piece of code can fully capture the memories a space creates in someone's mind. A large part of architecture exists beyond numbers and formulas. But there's another side to the story. Creativity doesn't come from intuition alone. It also comes from exploration. Sometimes the best idea isn't the first one that comes to mind. Sometimes it's the idea that emerges after exploring dozens or even hundreds of possibilities. And this is where coding can be incredibly valuable. Not because it replaces creativity, but because it creates more opportunities for creativity to thrive. Imagine you're designing a roof structure, a building skin, or a complex facade. If you try to explore every possible option manually, you'll probably stop after a few iterations. Not because there are no more ideas, but because your time and energy are limited. A computational system, on the other hand, can generate hundreds or even thousands of alternatives in a very short period of time. Perhaps 90% of them won't be useful at all, but hidden among them may be an idea you would never have discovered through a traditional process alone. That's why some architects see coding not simply as a design tool, but as a tool for discovery, a tool that expands the boundaries of what we can explore. However, there's one important thing we should never forget. Generating more options does not automatically lead to better design. If an architect can't evaluate those options, if they can't identify the strongest solution, if they can't consider spatial quality, beauty, culture, and human needs, no algorithm can do that for them. In the end, a computer can make suggestions, but it's the architect who must make the decision. So perhaps the better question isn't, does coding reduce creativity? Perhaps the real question is, how can we use coding to expand our creativity? And maybe that's the answer. Coding is neither the enemy of creativity nor a replacement for it. Instead, it can be a powerful tool that helps architects see more possibilities, experiment more freely, and design with greater awareness and confidence. At this point, some of these ideas might still sound a little theoretical, but the reality is that computational design and algorithm-driven workflows have been part of real architectural projects for many years. Let's look at a few well-known examples. The first example is Zaha Hadid Architects. If you've seen their projects, you've probably noticed that many of their buildings feature fluid, complex forms that look very different from conventional architecture. The obvious question is, how do you design something like that? And perhaps more importantly, how do you actually build it? The answer is that computational design tools play a major role in many of these projects. But what's interesting is that the goal isn't simply to create unusual shapes. When a project contains thousands of unique components or highly complex surfaces where every part is slightly different, managing that level of information becomes incredibly difficult without digital tools. So these technologies aren't used only for aesthetics, they're also used to manage complexity. Let's move on to another famous project, 30 St Mary Axe in London, often known simply as the Gherkin. What makes this building fascinating isn't just its distinctive shape. During the design process, digital analysis helped optimize the building's performance in terms of daylight, ventilation, and energy efficiency. In other words, the computer wasn't used merely for modeling, it also helped inform key design decisions. Another excellent example is Al Bahar Towers in Abu Dhabi. This project may be one of the best demonstrations of the relationship between architecture, environment, and algorithms. The building's facade isn't static. Its external shading system opens and closes in response to the movement of the sun. When solar exposure becomes more intense, the facade closes to reduce heat gain. As the sunlight becomes less intense, it opens again. The building is actively responding to its environment. Here, coding isn't being used simply to generate an attractive form. It's being used to solve a real-world problem. When we look at all of these examples, one thing becomes clear. In none of these projects was coding the goal. The goal was always to solve an architectural problem. Sometimes it was about managing complexity. Sometimes it was about improving energy performance. Sometimes it was about responding to environmental conditions. And sometimes it was about building something that would have been almost impossible using conventional methods. And perhaps that's the most important takeaway. When we talk about coding in architecture, we shouldn't think of it as a separate discipline. Coding is simply a tool. Its real value lies in the problems it helps us solve. So far, we've seen that coding can be an incredibly powerful tool for architects. It can help us understand systems more clearly, explore a wider range of possibilities, and deal with increasing levels of complexity. But we've also seen that architecture is about much more than technology. A large part of architecture still depends on creativity, human experience, and the architect's own judgment. So now, I'd like to hear from you. What do you think? Should coding become a core skill taught in architecture schools, or should it remain a specialized tool for those who are particularly interested in this area? Let me know your thoughts in the comments below. I'm genuinely curious to hear your perspective. And if you've made it this far, thank you for watching. If you found this video useful, please give it a like. It really helps the channel, and it helps more people interested in architecture and technology discover this content. And if you haven't subscribed yet, I'd love for you to join the channel and stay updated with future videos. Over the coming months, I'll be talking more about digital design, artificial intelligence, and coding for architects. I'm also currently working on a Python course specifically designed for architects, which I'll be releasing here on the channel in the future. So if these topics interest you, be sure to stick around and follow the channel. Now let's get back to the video. Even so, there are still a number of common misconceptions about coding in architecture. And for many architects, these misconceptions are often the reason they never explore it in the first place. Let's take a look at some of the most common ones. Misconception 1, I'm not good at maths, so coding isn't for me. This is probably the most common belief of all. Many architecture students assume that if they're not strong at maths, they'll never be able to learn coding. But the reality is quite different. Especially in architecture, coding is often more about logic than advanced mathematics. It's about breaking a problem down into smaller, manageable steps. For example, imagine you want the size of a window to change based on the amount of daylight it receives. You need to define what happens first, what conditions should be checked, and what action should be taken afterwards. That's much closer to problem solving than it is to solving complicated equations. Of course, some advanced projects may require a deeper understanding of mathematics, but for most people starting out, curiosity, logical thinking, and a willingness to learn step by step are far more important. Misconception 2. Coding is only for software engineers. This is another common assumption. When most people hear the word coding, they imagine a software developer sitting in front of several computer screens, writing thousands of lines of code. But that's not why architects learn coding. The goal isn't to build mobile apps or create social media platforms. The goal is to gain greater control over the design process. An architect's job is still to design spaces. Coding simply provides additional tools to help achieve that goal. In many ways, coding is just another language for solving design problems, not a career change. Misconception 3. Parametric design is only for futuristic-looking buildings. This misconception probably comes from what we often see online. Many of the most famous examples of computational design involve highly complex and visually dramatic forms, but in reality, many practical applications are far less spectacular. Imagine you're trying to find the ideal size for a shading device, or evaluate daylight levels in a school classroom, or compare different layout options for a floor plan. All of these tasks can benefit from computational methods. So, computational design isn't only about creating complex forms. Sometimes it's simply about solving everyday design challenges more effectively. Misconception 4. If everyone uses algorithms, all buildings will start to look the same. This concern is completely understandable, but if we look a little closer, we realize that algorithms don't design buildings on their own. They simply follow the rules that architects create. If two architects write different rules, if they pursue different goals, or if they're responding to different project conditions, the results can be entirely different. The tool may be the same, but the thinking behind it isn't. It's no different from giving two architects the same pencil and asking them to design a building. The tool is identical. The outcome depends on the person using it, and coding is no different. What creates the difference is the architect's vision, judgment, and way of thinking. In my opinion, most of the fears surrounding coding aren't really about coding itself. They're about the unknown. When we look at something from a distance, it often seems more complicated than it actually is. But the more familiar we become with it, the more we realize that coding isn't here to replace creativity. It's not here to replace architects. It's here to give architects more possibilities. So, we've arrived at one of the most common questions of all. If everything we've discussed so far is true, does every architect need to learn how to code? My short answer is no. I don't believe every architect needs to become a programmer, in the same way that not every architect needs to become a structural engineer, a building services engineer, or a software developer. But there is one important point. I do believe that architects of the future will need to develop a new way of thinking. A way of thinking often referred to as computational thinking. But what does that actually mean? Let's keep it simple. Imagine you're trying to solve a design problem. Perhaps you want window sizes to respond to daylight levels. Perhaps you want a form to react to the angle of the sun. Or maybe you want a floor plan to adapt based on several design constraints. The moment you start breaking that problem into rules, relationships, and clear steps, you're already thinking computationally, even if you never write a single line of code. And that's exactly why tools like Grasshopper have become so popular among architects. Many people assume that because they're not typing code, they're not programming. But if you look closely, you're still telling the computer what rules to follow. Take this input, check this condition. If this happens, produce that result. Instead of writing those instructions as text, you're connecting visual nodes together. But the underlying logic is exactly the same. That's why many architects see Grasshopper as an excellent starting point. It allows you to develop computational thinking without worrying about syntax or traditional coding. You begin to learn how to define problems in a logical and structured way. If you decide to go a step further, you'll probably hear a lot about Python. Python is one of the most widely used programming languages in the world, not only in architecture, but also in data science, automation, artificial intelligence, and software development. Within architecture, Python is used for many different purposes. Automating repetitive tasks, creating custom design algorithms, connecting different software platforms, and increasingly working with AI-powered tools and workflows. Alongside Python, you'll also come across languages such as C#. This is often used when developing more advanced tools, plugins, or custom software solutions. But if I could offer one piece of advice to most architects, it would be this. Don't start by asking yourself, should I learn Python or C# first? In my opinion, that's the wrong question. A much better question is, have I learned how to analyze design problems in a logical, step-by-step way? Because if the answer to that question is yes, learning any programming language becomes much easier. Tools change, software evolves. What's popular today may be replaced by something entirely different a few years from now. But the ability to think systematically remains valuable throughout your entire career. And perhaps that's the most important thing coding can teach us. Not the code itself, but the way of thinking behind it. Over the past couple of years, the rapid rise of artificial intelligence has introduced a new question to this discussion. If AI can write code, is learning to code still valuable for architects? It's a fascinating question, but perhaps we're asking the wrong one. The reality is that AI can already generate code. It can write scripts, it can identify bugs, and in many cases, it can dramatically increase the productivity of programmers. So the real question is no longer can AI code, because we already know the answer. Yes, it can. The more important question is, do we actually know what problem we're trying to solve? Imagine asking an AI system to create an algorithm that finds the best window design for a building. The first thing you need to define is this. What does best actually mean? The highest amount of natural daylight, the lowest energy consumption, the best view, the least amount of solar heat gain during summer, or some combination of all of them. And this is where the architect becomes essential, because defining the problem is still a human task. AI can help us search for solutions, but deciding what matters, which criteria are important, and which outcome is most appropriate for a particular project still requires human judgment. If you're interested in artificial intelligence and the future of architectural software, I've already published a dedicated video on this topic here on the channel. In that video, I explore how AI could transform architectural tools, what new capabilities future software may offer, and how these changes might affect the role of architects. So if you'd like to dive deeper into the subject, I highly recommend watching it after this video. I'll leave a link on screen and in the description below. In my view, the value of an architect in the future won't be defined by how well they use a particular piece of software, because tools will always change. The software that's essential today may be replaced by something completely different tomorrow. What will become increasingly valuable is the ability to analyze problems, to define constraints, to identify priorities, and to make informed decisions between competing options. AI may be able to generate thousands of alternatives, but deciding which one is most appropriate for a person, a community, a city, or a culture, that's still a human decision. And perhaps that's why the future of architecture won't belong simply to those who can design faster. It will belong to those who can think better, those who can ask better questions, those who can define problems more clearly, and those who can use new tools more intelligently in pursuit of better design. That's why I don't believe AI has reduced the value of learning coding or understanding systems. I believe these abilities are becoming more valuable than ever. When we understand how something works, we can use it in a smarter and more effective way. Artificial intelligence is a powerful technology, but people are the ones who decide how it will shape the future. One of the most important roles of architects in the years ahead may be this: not only learning how to use new technologies, but also knowing what ideas are truly worth creating. So far, we've focused on the opportunities that coding and computational tools can bring to architecture. Greater accuracy, more design options, better analysis, and the ability to manage levels of complexity that would be extremely difficult using traditional methods. But alongside all of these advantages, there's something important we need to remember. For all its power, coding cannot explain everything in architecture. Why? Because architecture is not only about solving technical problems. Architecture is about people. Imagine walking into a historic building. We can measure the amount of daylight in the space. We can calculate the height of the ceiling. We can analyze patterns of movement. We can even evaluate the building's energy performance. But can we accurately measure why a space feels special? Why a room creates a sense of calm? Why a courtyard leaves a lasting memory? These are the parts of architecture that will always exist beyond numbers and data. An algorithm can tell you that one solution performs better than another. A simulation can show which option consumes less energy, but the feeling a space creates, the way it connects to a culture, or the story it tells, these things cannot be defined by calculations alone. And this is exactly where the architect becomes essential, because an architect is not simply someone who solves problems. An architect is someone who balances competing needs between performance and beauty, between technology and emotion, between data and human experience. Perhaps one of the biggest mistakes we can make is to assume that anything which cannot be measured must somehow be less valuable, when in reality, many of the qualities that make architecture meaningful are precisely the ones that resist measurement. A building is not just a collection of walls, materials, and calculations. It's a place where people live, where they work, where they create memories, and where they experience life. So perhaps the best way to think about coding is not as a replacement for architecture, but as a new tool within architecture, a tool that helps us understand problems more clearly, a tool that helps us make better decisions. But ultimately, it's still the architect who decides what is worth creating. Because in the end, not everything valuable in architecture can be measured. And perhaps that's exactly what makes architecture so special. Throughout history, architecture has always evolved alongside technology. There was a time when everything was drawn by hand. Then digital tools arrived. Software changed the way we design. And today, coding, computational design, and artificial intelligence represent the next stage of that journey. But perhaps the most important question isn't, should architects become programmers? Perhaps the more important question is, should future architects become better at understanding systems? Because the buildings of tomorrow will probably be shaped by more than lines and forms alone. They will emerge from a combination of ideas, data, algorithms, and human decisions. Perhaps the architect of the future won't simply be someone who designs more buildings. Perhaps it will be someone who can understand greater complexity, a person who values creativity and new possibilities. New technologies can open new paths for design and innovation. The future of architecture will always depend on human ideas and decisions. Technology can support the creative process, but the vision, the purpose, and the imagination come from people. Architects who learn to work with new tools will have new opportunities to create meaningful spaces. So now I'd like to hear your opinion. What do you think? Should architecture schools teach coding as a core skill, or should it remain a specialist tool for architects who choose to pursue it? Do you think architects will become programmers in the future? Or will creativity, judgment, and human decision-making always remain at the heart of the profession? Let me know your thoughts in the comments below. I'd genuinely love to hear how you see the future of architecture. Thank you for watching, and thank you for staying with me until the end. I'll see you in the next video. Goodbye.